I'm going to go through 3 examples of how we've made enhancements for 3D at 10. I'm going to first look at how we can use a virtual city to show how we can have improved our performance. Next, we'll move and look at some editing and analytical workflows, and then I'll wrap things up by showing you how we can incorporate video into 3D. So to begin, one of the big performance enhancements we've made at 10 is the ability to really be able to leverage and use 2D online content like this topo map service. Another type of map service that's really important, of course, is imagery. There's a lot of content available for imagery, but also image services. So this is an example of a 4-inch image service that's provided by the city of Philadelphia. Now, using this high resolution imagery, we're able to see this train track here. It looks like it just stops. But when we turn on our high resolution elevation model, which was built from LiDAR, we can actually see that it's a tunnel entrance. So as I'm building up this virtual city, the next thing we want to add, of course, is some very good-looking building models. These were provided to us from Pictometry and Precision Lightworks. And as I zoom in, you'll notice that the level of detail changes with the view distance. This is one way we've been able to improve performance of these high-resolution building models. Now we're going to just move on over to Logan Square real quick and have a look at other GIS layers that we want to bring into our virtual city, like street furniture and vegetation. Now these are GIS layers just like the buildings and can be used in analysis. And that's what and a sample of this data and the workflows that are used to maintain and update the data will be made available as a virtual city template on our resource center. So the next workflows I'm going to go through is the editing and some analysis. And this time we're using that exact same Philadelphia data set, but this time as a 3D thematic map. Sometimes there's proposed buildings that need to be put in place to see how they impact the space. And in this case, we're going to add a building to these vacant parcels. Now I'm just going to go ahead and start editing. And this is new at 10, the ability to start editing in 3D. And I'm presented with the same editing experience, the template-based editing experience that Nikki showed earlier. So I can just go ahead and add the location of our proposed building and select a building model to represent that building, in this case a SketchUp file, and it's automatically, with one click, geo-referenced and placed in the placed. Now I can rotate that model to make sure that it's oriented correctly on our parcels. And of course I can edit the attribution, like the contact name. And I'll go ahead and add in the date submitted. Now, one thing about editing model data like this is that we can actually update that building model with a new representation without having to re-enter the attribute information. So I'll go ahead and stop editing and save my edits. And now we have that new proposed building in its correct location. Now, more than likely, this new building will block the view of Logan Square for several apartments in the neighborhood. So we want to perform a quick line of sight analysis to determine exactly which apartments will have their views blocked. New at 10 is the ability to use multi-patch features in that analysis. And so we've highlighted in red those apartments who will have their views blocked. So one last analysis I want to go through is using the Skyline tool. I believe John mentioned the Skyline tool earlier today. I'm going to use that over at Independence Hall. Independence Hall is a national treasure maintained by the National Park Service, and one of their key considerations is maintaining the colonial aesthetic of the site. In this case, we can use the Skyline tool to create what in effect is a virtual barrier to any new development that would impact that colonial aesthetic. Now, I've only shown a small sample of the analytical tools that are now available at 10 for 3D. And the final thing I want to show is how we can incorporate video. So here we're looking at the San Francisco Bay Area. I'm going to turn on a video layer, which is one of our new layer types at 10. Go ahead and play it. As it plays, I can interact with the map. I'll tilt the map so you can see that it's draped on the surface. And of course, I can pause it or restart it however I like. And I'll go ahead and change the transparency so we can see our underlying GIS data. This is an example of a geo-referenced video, so it drapes on the surface. Another type of video that's very important for us to be able to use is when we know the camera's location and its orientation, such as those found in persistent surveillance systems. So we're going to zoom over to Redlands real quick and have a look at one of our security camera feeds from the parking lot. I'm going to turn that on and go ahead and play it. So again, this is a really important way to bring video into 3D GIS. So to summarize, we think 3D is one of the integral parts of GIS, and we've made significant strides in how we display, analyze, and maintain that 3D data at 10.